Okay, Common Core Geometry kids. This is going to be our first lesson on trigonometry. Okay, so what is trigonometry? Well, tri means triangle, right? Gano, I looked it up once in Latin. I think it's angle measurement. You can look it up if you want. And metry is measure. Okay, anyway, what is trigonometry? Trigonometry is based off of similar triangles, all right? It's based off of CSSTP, and it's based off of angle is congruent to angle. So what trigonometry is about, the spirit of trigonometry, all right, it's the relationship between sides and the acute angles of right triangles. All right, so what am I talking about? Well, there are two similar triangles. So let's say we have two triangles, okay, which are similar by side. Okay, we'll actually do side angle side here. So I'll make these right angles. We'll say that this is 3, this is 4. And we'll say this is 12, this is 16. So these two triangles are similar. Okay, we'll call this triangle A, B, C, and triangle D, E, F. They're similar by side angle side. Triangle A, B, C is similar to triangle D, E, F by side angle side. Okay, what does that mean? That means you have two pairs of sides that are in proportion. So 16 to 4 is equal to 12 to 3, which is true. Both cross products are 48. And the angles between are congruent. Well, all right angles are congruent. So therefore, these are similar. Okay, so who cares, right? Well, the way that this works, guys, all right, is that because these are similar, they create certain angle measurements. So because they're similar, angle C is congruent to angle F, because in similar triangles, the corresponding angles are congruent. Okay, and the same thing with angle A and D. All right, so these angles are going to have certain measurements, okay? There's going to be 3 trigonometric ratios, and that's what I'm going to show you. Okay, so you remember when we learned special right triangles, and we had the 30, 60, 90 right triangle? This was our last lesson. So let's say this is 60 degrees. I don't even have to tell you the 30. But let's say this is 8. And then we have the side across from 60 would be 8 rad 3. And the side across from 90 would be 16. So there is a relationship amongst this angle, between this angle and these sides. So let's show you the trig ratios. Okay, we're going to talk about 60 degrees. So let's say we're talking about the cosine of 60 degrees. All right, what is cosine? So we have the saying, it's called so, ka, toa. What does this stand for? Well, S stands for sine. The O and the H stand for opposite. So that means the side opposite the angle we're talking about. And H always stands for hypotenuse. Okay, cosine is adjacent Now, the hypotenuse will always be adjacent to the angle as well, but you use the hypotenuse is already called the hypotenuse, so you can't call it the adjacent as well. So the adjacent and the hypotenuse form the angle. And then the last one is tangent, which is opposite over adjacent. So it's the only one that does not have the hypotenuse involved. Okay, and you can remember these by SOHCAHTOA. Now on your calculator, you will see sin, cos, and tan. And you're going to need your calculator all week, and you're going to have to be in degree mode. Okay? All right, anyway. So let's talk about the cosine of 60. So cosine of 60 is going to be the adjacent over the hypotenuse. Well, the hypotenuse is 16 here. The adjacent is the other side that forms that 60-degree angle. So sine of 60 is adjacent over hypotenuse, which is 8 over 16, so it's 1/2. Now let's say we're talking about, that's cosine of 60. I think I said sine by accident. Let's talk about sine of 60. Now, by the way, it's not going to be written cosine, it's just going to be written cos 60. So sin of 60, sine of 60, would be opposite over hypotenuse. So that would be 8 rad 3. So this is adjacent, this is hypotenuse, this is opposite, over 16. And then you have, okay, so this ends up reducing to rad 3 over 2. And then you have your tangent of 60 degrees, which is going to be opposite over adjacent. That's your opposite, your adjacent. So it ends up just being rad 3. Okay, so with the similar triangles, so if I had two triangles, let me make two other triangles. Let's say this is 30 degrees. And then I make a smaller version. All right, so let's say this is 4 and this is 8. All right. And then I have, all right, the hypotenuse. I'll do the hypotenuse. Okay, it's 16 and it's 8 here. So if I'm talking about, say, the sine of 30 degrees in this triangle, it would be opposite over hypotenuse. Okay, well, the side that's opposite is 4, and the hypotenuse is 8. So it would be 4 over 8, or 1/2. So here's the thing, because these two triangles are similar, this sine is the same. The sine of 30 degrees is always going to be the same. And that's the spirit of trigonometry, because 8 over 16 is the same as 4 over 8. So no matter what triangle you have, no matter what right triangle you have, whatever angle you have, okay, your relationship, your sine or cosine of that angle is always going to be set. Okay, so let's just finish this out with making sure you understand it. So let's say I have this triangle here. This is 30, 34, 16, G, H, I. And I'm going to ask you a series of questions. We're going to have the sine of G, cosine of G, tangent of G. And then we're going to have the sine of I, cosine of I, tangent of I. So when you're dealing with G, the side that is opposite is the 16. Okay? So it's going to change depending on which angle you're looking at. So the opposite is 16. The adjacent is 30. And the hypotenuse is 34. However, for angle I, the opposite is 30. The adjacent is 16, but the hypotenuse stays true and steady. That doesn't change. So the adjacent and the opposite change depending on which angle you're talking about, which acute angle you're talking about. Okay, so we have so, ka, toa. So sine is going to be opposite over hypotenuse. And then you can reduce it to lowest terms if you want. Okay, the cosine is going to be adjacent over hypotenuse. Write it in lowest terms. Tangent, opposite over adjacent. Okay, so then your sine, okay, for I, your opposite is now 30, right? Your adjacent is still 34, so you get 15 over 17. So notice the sine of I is the same as the cosine of G. And then the cosine of I is adjacent over hypotenuse, which is 8 over 17. So you can see that the sine of G is the same as the cosine of I. And then the tangent of I, remember your opposite and adjacent change, so it's the reciprocal of the tangent of G. These little clues will help you if you're ever in doubt. Now, they don't have to be so nice, by the way, to give you all three numbers. You could end up having to use the Pythagorean theorem. There could be 45, 45, 90 isosceles right triangles. There could be 30, 60, 90 right triangles. And then you have to bring in your prior knowledge. So there are ways that they can make this challenging. Okay, I'm going to end this video with a Regents question. It was a Regents question. The diagram below shows two similar triangles. All right, and then they try to confuse you because they don't draw them in corresponding position. This is called theta, by the way. You will sometimes see that in a picture. You'll see this symbol for alpha. You'll see the symbol for beta. Just letting you know. Okay, these things will come up. I don't want you to be confused when you see them. Okay, instead of like calling this A, okay, they call it theta. So they could actually put it in the angle instead of at the vertex. That's the difference. So number one, they're not going to be so kind. Oh, they were kind enough to tell you they're similar triangles. They did not have to do that because these are similar by angle. Now here's the question. If tangent of theta is 3 over 7, what is the value of x to the nearest tenth? Okay, kids, so we're looking for the value of x. Now, theta is 3 over 7, right? These are similar triangles. So let me put I want to find x, right? So let's call this theta, since they're congruent. We'll call this theta sub 1, theta sub 2. Theta sub 1 is equal to theta sub 2. Right? The measure of angle. The measure of angle theta sub 1 is equal to the measure of angle theta sub 2. All right, anyway, so the ratios are going to be the same, right? So tangent of theta sub 1 is going to equal tangent of theta sub 2. They have to be the same because these are similar triangles, so the ratio of the corresponding sides are equal. And when you have angles that are congruent, those ratios will be equal. So we know that this is 3/7. Okay, so now we're going to represent tangent of theta sub 2, which is opposite over adjacent. Okay, kids, so now you're going to have to cross multiply and solve this proportion. To do this without a calculator, I'm going to divide both sides by 3, dividing 2.4 by 3, which is 0.8. And then 0.8 times 7 will be my answer, which is 5.6. So when it's said to the nearest tenth, they just do that to cover themselves, but it actually came out to be exactly 5.6, so you didn't even have to round it. But that's what the Regents does, okay? That's how they challenge you. They're not going to be so straightforward. You're going to have to make connections, and that's the entire purpose behind the Common Core curriculum. All right, kids, hope you enjoyed this video. See you in class. Thank you.